So Rohini College of Engineering and Technology from Department of Civil Engineering. So this is our final year civil engineering subject, 7th semester. So our subject title is C8703, Structural Design and Drawing. I am Michael Devadurai, Assistant Professor. Today we will see about the topic is design a hand operated traveling crane. So example 2. So design a hand operated traveling crane is simply supported by Gantry girder for the given data. So span of Gantry girder is equal to 5 meter. Then span of crane girder is equal to 15 meter. Then crane capacity is equal to 200 kilonewton. Then self weight of crane girder is including trolley 200 kilonewton. Then self weight of trolley is equal to 30 kilonewton. Then minimum hoop approach is equal to 1 meter. Then distance between the wheels, because the wheels means the vehicle means in distance between the two wheels is 3.5 meter from center to center distance. Then self weight of the rails is equal to 0.3 kilonewton per meter. Then step number 1. So for calculating maximum moment, so a self weight of the trolley plus a load lifted by the crane is equal to, we know the weight of trolley is given in our question. So load lifted by the crane also given in our question is the 200. So 200 plus 30 is equal to 230. So see the diagram, we have marked at the loads. Then self weight of the crane girder is equal to 200 kilonewton. That also marked in our diagram. See the diagram, RA and RB. Then span is the 15 meter. Then from 1 meter, because the hook is the 1 meter from there. So hook is the 230 mm weight, and the UDL is the self weight of the girder is the full and full up to A to B. So here is the 200 kilonewton. So we will mark that the UDL, based on UDL 200 kilonewton. For maximum reaction on the gantry girder, the moving load should be placed close to gantry girder. Then sum of moment is equal to 0, that is the taking moment of all forces about B. So RA into 15 minus 230 into 7.5. So RA is equal to 4720 by 15 is equal to 314.67 kilonewton. Then this total is transferred to gantry girder through the two wheel base, which are at 3.5 meter center to center distance. Then load on girder from each wheel is equal to, we need to load, say loads will be found out at 314.67 kilonewton, but we need that the each wheel. So separate the each wheel. So load divided by 2. So 314.67 divided by 2 is equal to 157.33 kilonewton. Then factored wheel load means simple, that load will be multiplied by 1.5. So because 1.5 is our constant factor load, so we got the 236 kilonewton. Then see the diagram, just to mark the values, 236 kilonewton load, wheel loads. Then 0.75 the distance, so 1.75 is also. Then total span is the 5 meter, so 2.5 split into, then 1.65 the remaining sides. So the two wheel loads between the 3.5 meter, then the maximum moment due to the moving loads under a wheel load, the center of gravity. So wheel loads are, and the wheel are quick distance from the center of girder. So RB is equal to, we are taking moment about here, RB is equal to taking there. So RB is equal to 236 into 0.75 meter, then 236 into 2.5 plus 875, because two spacings are there, divided by 5. 5 means the full spacing. So equal to 194.7 kilonewton. Then maximum moment at E is equal to 194.7 into 1.625 from support B. Okay, so is equal to 316.38 kilonewton. The moment due to impact, so that will be one impact will be formed. So normally all the problems with the maximum moment are directly even find out the AST, but in this steel structure some of the moment is formed there. So again the impact force is also there, because vehicles are suddenly coming there, so moment due to impact. So 20% of maximum moment will be taken at the impact positions. So 0.2 into 316.38, then 63.277 kilonewton meter. Then assume self weight of the girder is equal to 2 kilonewton per meter. Dead load due to self weight is plus rails equal to 2 plus 0.3 is equal to 2.3 kilonewton per meter. So the assuming the self weight of girder is, you can assume a 1 kilonewton or up to 4 kilonewton, you can assume the self weight. Then factor load is equal to 2.3. So factor load is the 2.3 into 1.5 is equal to 3.45 kilonewton per meter. Then moment due to dead load. So we know the simple moment formula WL square by 8. From second year onwards we get to study about the bending moment formula WL square by 8. So simple formula. So we know the W is the 3.45 and L is the 5 meter. So 5 square divided by 8. We got the 10.781 kilonewton meter. Then factored moment is due to vertical load. M is equal to 10.781 plus 63.277 plus 316.38. So is equal to 390.438 kilonewton meter. Then maximum moment due to horizontal force. So horizontal force transfers to rails. 10% weight of trolley plus lifted. Because the horizontal force it will be trolley lifted weight also added to this weight. Then 10% means 10 by 100 into weight of trolley is the 200 plus weight of it is the 230. So 23 kilonewton for horizontal force. Then assuming double framed wheels. So this is distributed over 4 wheels. So horizontal force on each wheel. So we needed the horizontal force on each wheel. So each wheel means 23. So 23 divided by 4. So 5.75 kilonewton. Then factored horizontal force on each wheel is equal to simple multiplied by the factored load. So factored constants is 1.5. So 5.75 into 1.5. So is equal to 8.625 kilonewton. Then for maximum bending moment in Gantry girder, the position of load is same except in horizontal. Then MO is equal to 8.6525 divided by 236 into 316. So answer is 11.56 kilonewton meter. So see the diagram. So finding out the shear stress. Step number 2, finding out the shear stress, shear force. So A and B support. The support is a 236. The length is 3.5 meter. The full span length is 5 meter. So remaining after the load will mark to the 1.5 meter. So for maximum shear force on the girder, the traveling wheel should be just on the girder. So vertical shear due to wheel loads is equal to 236 plus 236 into 1.5 divided by 5. So we got the 306.8 kilonewton. So vertical shear due to impact. So because already I told that the impact will be formed based on suddenly acting some of the loads. So we can provide a 20% of the load. So 20% means 0.2 into that vertical shear force load. So 0.2 into 306.8 is equal to 61.36 kilonewton. Then vertical shear due to self weight is equal to W by 2. So equal to 3.45 into 5 by 2. So is equal to 8.625 kilonewton. So the total vertical shear is equal to 306.8 into 61.36 plus 8.625. So we'll add all the vertical shear force. So finally the total vertical shear force is equal to 3376.785 kilonewton. Then by proposing the lateral shear due to surge, so is equal to 8.625 divided by 236 divided by into 306.8. So is equal to 11.21 kilonewton. So step number 3, selection of this section. So first we designed all the loads and shear force and bending moments also we already find it. But now we can the selection of the section. So how to find the selection? First we can the economical depth of the section. So the L by 12. So L by 12 means L is the span length. So 5 meters we convert into mm. So 5000 divided by 12 is equal to 416 is equal to 500 mm. So step now second condition is the compression flange with L by 25 is equal to 5000 divided by 25 is equal to 200 mm. So let us try ISWB 500 with ISMC 300 on compression flange. So just we can try the one section. So we have selected the ISMC 300. So properties of ISWB 500 at 9.52 Newton per meter. So properties of ISMC 300 also. So area is equal to 12,122 mm square. So for IMC 300 is equal to 4564 mm square. Then H is equal to 500 mm. Then on the other side H is equal to 300 mm. So BF is equal to 50 mm. So for ISMC 300 is equal to 90 mm. So TF is equal to 14.7 mm. That is the TF is equal to 13.6 mm. So intersection TW is equal to 9.9 mm. So ISMC 300 section for TW is equal to 7.6 mm. Then IZ is equal to 522.90 and 10 power 6 mm power 4. Then that is a YZ is equal to 6362.6 into 10 power 4 Newton mm power 4. Then IYY is equal to 29.878 into 10 power 6 mm power 4. So IYY is equal to 310.8 into 10 power 4 mm power 4. So CYY is equal to 23.6 mm. So this is our I section. So mark all the values, flange values, web values, and YP values, Y values, then width of the values. Okay. Then to find the neutral axis of the section from bottom flange tension. So Y bar is equal to, so apply all the values in our Y bar values. You got the Y bar is equal to 314 from bottom flange. So I is equal to, we know that 522.90 10 power 6. Apply all the values. So I is equal to 1.015 into 10 power 9 mm power 4. Then Z is equal to I by Y. So we know the common formula Z is equal to I by Y. We know that I and Y formula. So apply the 1.015 in 10 power 9 divided by 314 mm. So Z is equal to 3233 in 10 power 6 mm cube. So for compressive flange about YY axis, so IYY is equal to 14.7 into 250 cube divided by 12 plus 6362.6 in 10 power 4 is equal to IYY is equal to 822.76 in 10 power 6. So this IY formula is a BDQ by 12. This is our formula. So we can easily find out that. So ZEY for compression flange is equal to I by Y. So 82 is I, Y is 150. So you got the 551.77 10 power 3 mm cube. So now plastic modulus of section is the total area of the section is equal to add the total sections. So you got the 16686 mm square. So let plastic neutral axis, it will be distance YP from the bottom flange. So YP minus 14.7 because we taken from our bottom face is equal to A by 2. So because the area by 2, this is a condition of the formula. So apply the area values 16686 by 2 is equal to. So we can easily find out that calculating from YP. YP is equal to 4813.53 divided by 9.9. So is equal to YP is equal to 486.21 mm. So plastic moment capacity of this section. So MP is equal to sum of moment of forces at yield about plastic neutral axis. So MP is equal to 147. This is the bending moment formula. So you can apply all the values. We know that. So easily you get the answers. Then 1.75 in 10 power 6. This is our answer. Then 1.793 into 10 power 6 into Fy. Fy is the constant. Then ZP is equal to MP divided by Fy. So ZP is equal to 1793 into 10 power 6 mm cube. For top flange, ZPY, also we know the formula MP by Fy. So apply all the values. We know all the values also we know that. So apply it. ZPY is equal to, we got the answer step by step. You can calculate in your calculator using check the answers. Okay. So ZPY is equal to 721.62 in 10 power 3 mm cube. So check for moment capacity. So B by T of flange of ISW 500. So is equal to flange value. So depth of B. So B is equal to 250 minus 9.9 is that value. So minus this is. So T is equal to thickness about the two flange thickness. So 14.7 into 2 because two flanges we have. So answer is the 8.16. So our section is 8.4 below the 8.4. So the depth of the web section is the 84 below the 47. Okay. So but the B by T of the flange of the channel section is the IMC below the 8.4. Then this section is the plastic section. So above the 8.4 section is the compact, semi-compact section will be changed. So all the answers will be the below the 8.4. So this section is the plastic section. So local moment capacity for bending moment in vertical plane. So MD is equal to Fy ZP. So 250 407.5 kilonewton meter. So apply all the values. You can know that finding out the ZTFY by 881.721 kilonewton meter. This is our bending moment. So lesser values of two MDZ. So we have MDZ and MDY. So lesser value is 407. So we can take as that value. So for top flange MDZ is equal to Fy into ZP divided by 1.1. So is equal to MDY. So 164 kilonewton meter. So again you find out the MDZ and Fy is equal to 150.58 kilonewton meter. For top flange MD is equal to 150 is equal to MDY. Is equal to that. Then check for the combined local capacity. So Mz divided by Mdz plus My divided by Mdy is less than 1. So hence this section is, we know all the Mz and Mdz value and Mo and Mdy z value. So less than 1 is equal to, this section is adequate and economic. So check for the buckling resistance. So Md is equal to, this formula is in our code book taken from IS 800 2007 page number 73. So all the values if you know, beta B is equal to 1 for plastic section. So FCR and B. So this value is taken from our code book page number 31 for compressed section. So all the values are, if you know that. So first one LLT is equal to 5 meters, so 5000 mm. So LLT means is nothing but is the effective length of the span. So effective length of the span is 5 meter. So E is equal to constant value 2 in 10 power 5 Newton per mm. So the steel sections. Then HF is equal to 500 plus 7.6, 507.6. Then TF is the 14.7 mm. And the IY is equal to, we know the formula, they apply that. Then area is equal to 16686.6 mm square. Then FO is equal to, we know the formula, applied 74.85 mm. So FCR is equal to FCB or is equal to all the values if you know. So apply it, just the answer, all the values. So FCR is equal to 530.165 Newton per mm square. So IS code IS 800 2007, the class 8.22. For FCB is equal to 530.6. So FBD is equal to 191.134 by linear interpolation. So MD is equal to 1 into 191.34 into. So because we need to find out all the values based on this step. So check for biaxial bending also. So MDY is equal to Fy Zy divided by GAM 1.1. So we know the Zy formula Iyy by 150. So MDY formula is the, you know that. So Zy and MDY you find it. You find out the 141.67 kilonewton meter. So see the diagram. So all the values marked on the diagram. 157 is the load, and E and EA is a constant value. Then 0.75 distance left side of the load. So distance between the two loads it is the 3.5 meter. The full span of the lens is the 5 meter. So MD MZ by MDS plus MY divided by MDY is less than 1. So all the values are already find it. So apply the value. So section is the hence safe, or check the adequate and the section. So check for the deflection. So at the working load, the deflection is limited to L by 750. So maximum deflection occurs midspan is equal to moment of M by EI in conjugate beam. So moment of M by MEI load in conjugate beam. So reaction in conjugate beam is equal to 1 by 2 into total moment M by EI diagram. So 1 by 2 into 0.75. So EI 118 into 5 by 2. So apply all the values, you get the reactions. So 339.25 divided by EI. Then EI delta is equal to, that apply the values. You got the answer is the EI delta is equal to 578.94. So EI is equal to 2 into 10 power 5 into 1.01 into 10 power 9 divided by 10 power 3. So 203 into 10 power 3 kilonewton meter square. So delta is equal to 2.85 into 10 power 3 10 power minus 3 meter. So 2.85 mm. So permissible deflection delta is equal to L by 750. So L is known value 5000 mm. So 750 is equal to 6.67 mm. Deflection required is satisfied. Hence IS WB 500 with ISMC can be suitable for gantry girder. Thank you.